Hello everyone. In this video, we are going to talk about preventing lost updates. Lost updates happen when you have two transactions that are performing a read, modify, write cycle at the same time. For example, two users incrementing a counter concurrently or updating the balance after checking what the initial value is and editing JSON documents or wiki pages. And because and this happens because both the transactions read the same initial value and then they calculate the new value and write it back. And the second write wins or overwrites the first update. And some of the solutions to prevent last updates is atomic operations. These atomic write operations encapsulate a read, modify, write operation into a single indivisible command. And most of the relational databases provide this. And these avoid lost updates by removing the opportunity for another write to sneak in between the read and write. And simple queries like update counter to set the value of the current value equal to value plus 1. And some databases also offer atomic modifications for documents and data structures. And this is usually implemented with exclusive logs and single thread execution. And it's a best choice if your write operation can be represented atomically. Then the second option is explicit locking. Explicit locking happens when you have application that explicitly locks rows before updating. So within a transaction, you first do a select and then do the update. And this is very useful when you have a logic that is complex and it cannot be represented with atomic writes. And it is also sometimes easy to forget the logs uh, because of lack of awareness by the application developer, and it could result in race conditions. Next one is compare and set operations. In compare and set operations, we try to avoid the lost updates by allowing the comparison of that value before making the update. That means you you continue with the update operation only if the value has not changed since it was last read. For example, something like update the page and set the content equal to new content where id equal to xyz and the content is equal to old content. So the record only gets updated if the content is has not changed since it was last read. That means the operation can also fail if the value is not matching, and it's the responsibility of the application to retry it if the condition fails. And some databases also, if they provide a way to read the old snapshot of the data, this might fail. So it's better to understand the safety and snapshot isolation provided by your database before implementing this. And coming to the replication context, in replicated databases, there will be multiple copies of your data, and this makes it complicated to prevent the lost updates. Because all the previous ones that we have seen, like explicit logs or compare and set, they assume one single up to date copy, but it doesn't work in replicated databases. And one common approach that is followed to prevent lost updates in replicated databases is you allow the conflicted versions or siblings to be written and then merge the updates later, either with application logic or have your database itself resolve those conflicts. And atomic write operations work well if those write operations are commutative. What that means is your update can work, your updates can work irrespective of the order in which it's executed in these replicated copies. For example, incrementing counters. It can uh, it can be executed in either order, but the end result will still be the same. But if you have scenarios where you have the last write wins, then it could result in lost updates. So it's important to understand the isolation levels provided by your databases and your application requirement, and implement the right methodology to prevent lost updates. Thank you.